Hey guys, welcome. Yeah, so in this video, I'm going to show you binomial expansion using Pascal's triangle. And for additional examples, and also because you can do binomial expansion without Pascal's triangle, I will have at least 2 more videos on binomial expansion. And yeah, all right. Now to start, let's look at the binomial a plus b and raise it to the 0th power. And if all along you didn't know what I meant by binomial, we just mean something that can be written with 2 terms, right? So something that can assume the form a plus b. One example is like 2x minus 3, because you can write it first as 2x plus a negative 3, and then a is 2x and b is negative 3, yeah? And so you're not limited here. You can expand any binomial using the method I'm about to show you here. Yeah? Okay, cool. Now, we know that a plus b to the 0th power is 1, and that corresponds perfectly with Pascal's triangle's first line. So in the first line of Pascal's triangle, you just write a 1. And notice that the first line of Pascal's triangle corresponds to the 0th exponent on our binomial. Yeah? Okay, cool. Now let's next move to a plus b to the first power. And we know that that's just a plus b, but I've written the coefficients in front of a and b so that you can easily see that it's in perfect alignment with Pascal's triangle. And that's because the second line in Pascal's triangle is just a 1 and 1, and that's what we have here, a coefficient of 1 in front of a and a coefficient of 1 in front of b. Yeah, cool. And the next thing we're going to do is look at a plus b to the second power. A plus b to the second power is, well, if you expand it and collect like terms, it's a squared plus 2ab plus b squared. And again, I've intentionally written these unnecessary coefficients of 1 in front of the a squared and 1 in front of the b squared so that you can see that this is directly related to Pascal's triangle's third line. And again, just a quick reminder, the third line in Pascal's triangle corresponds to the second exponent. The second line in Pascal's triangle corresponds to the first exponent in our binomial, and so on. Yeah? Okay, cool. And I'll explain, how these other terms a and b can be gotten very easily, just as easily as we write the coefficients. But let's keep this going first. All right. And before we keep going, you see this 2 is a sum of this 1 and this 1 here. In the first line of Pascal's triangle, we just had to write a 1. And in the second line, since we had to go from like 1 item in the first line to 2 items in the second line, we just write a 1 and 1. And as you'll see in more lines of Pascal's triangle to come, the leftmost number and the rightmost number in each line of Pascal's triangle are always going to be a 1. And therefore, on the third line of Pascal's triangle, we had to start with a 1 and with a 1, but this middle number 2 is a sum of these 2 numbers, 1 and 1. Yeah? Okay, cool. That's important to keep in mind. So now let's go to a plus b to the third power. And again, if you expanded using other methods and then collected like terms, you'll see that a plus b quantity cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. Again, I've written a 1 here and a 1 there, so you can see that this, again, is perfectly aligned to Pascal's triangle. And this time to the fourth line for the third exponent here, right? And in the fourth line, we have 1, 3, 3, 1, and you get that because, again, we start with a 1 and end with a 1, but 1 plus 2 makes this 3, and then 2 plus 1 makes this other 3. Yeah? Okay, cool. Next, you get it, right? I don't think I need to talk here. And here's the next line in Pascal's triangle, and this 4 is the sum of 1 and 3. The 6 is the sum of 3 and 3, and this second 4 is the sum of 3 and 1. Yeah? Okay, cool. Here we are on the 6th line of Pascal's triangle, which we know should correspond to a plus b to the 5th. So let me write that, a plus b to the 5th. And sorry, I'm going to betray my color coding. My writing, I'm not in love, but all right, a plus b to the 5th. Yeah, okay, cool. First, we know that the coefficients are just the sixth line in Pascal's triangle. So let's write those down. 1, and then 5, and then 10, and then another 10, and then a 5, and then a 1, right? Okay, cool. Now let's talk about how to get the exponents on a and b and the exact terms that correspond to these coefficients. Well, if you look here, I wrote a cubed, and if I so chose, I could write b to the first. And then here also I could have written a to the first. So we have a 4 here. Sum of the exponents is 4 there. Sum of exponents is 4. And so the sum of the exponents is 4, or the exponent is 4, right? Well, first you see that this is a 4, and we start with a having all of the power. A starts with all of the power that we have on a plus b, right? So then we should write a to the 5th to start. And technically, we should multiply this with multiply by b to the 0th power, but b to the 0th power is 1. But the point is that a starts having all of this exponent, and then b has none of it, and the other parts, b will gain 1 and a will lose 1. So a will go to a to the 4th power. It started with a to the 5th, and then now we'll have b to the 1st power. That was poor. B to the 1st power, yeah? And then plus, and now it will be a to the 3rd, so a loses 1 more, and then b gains that lost power from a, and then plus, and then it's a to the 2nd, and then b to the 3rd, and then plus a to the 1st, or just a, and then b to the 4th, and then plus, you get it, a to the 0th, which I'm not going to bother writing, but b to the 5th, and this completes it.